Hi, Yes. Thanks so much for the introduction, and thanks to everyone for joining me today for my Raspberry Pi 101 webcast. My goals today are to explain exactly what a Raspberry Pi is, why you would want one, what you're going to need to get started with one, and then towards the end we're actually going to jump onto one and figure out how to set one up. I'm going to do my best not to get too technically deep, but if there are points during the conversation where it sounds like I'm speaking Klingon, don't get frustrated. There's nothing highly technical on here that you need to know that's going to get in your way of getting started and working on a Raspberry Pi. Most of what I'll be sharing today has come up from frequently asked questions of me and during conversations in Raspberry Pis where people really want to know what is it all about, what's the big deal, and what do I do with it. So without any further ado, I'm going to get right into what is the Raspberry Pi. The short and fast answer is that it's a $35 personal computer. And while that's a very simple answer, the history and the story behind the Raspberry Pi and the foundation is what makes it pretty interesting. In 2006, a group of colleagues at the University of Cambridge got together and started collaborating and designing and testing a way to manufacture a computer that would be cheap and small and essentially made for children. I'm sure you can imagine the potential in being able to make computers that are small, easily portable, and widely available. So they spent about 5 years prototyping, designing, testing, struggling, getting through compliance, and finally in 2011 they started shipping the first Raspberry Pi units. To date, they're producing at least 4,000 units a day with plans to produce many more, and they've already shipped over 1 million Raspberry Pis. It comes without a case, and it's a very, very bare-bones system. But with power, keyboard, an SD card, and a monitor, you have a full-feature computer that works about as well as a PC that you would have paid $2,500 for 10 years ago, with the added benefit of running on old or new visual hardware. So you can run on HDMI cables, and at 720p it actually works very well at a high resolution. But it's also compatible with older monitors, so if you don't have the fancy new LCD screen, you can hook it up to just about anything. So you find that really it's just a small computer without a case, and it doesn't seem so exciting. It's actually not much bigger than an Altoids case. It doesn't quite fit into one. It uses an old SD camera card as its hard drive, and for the last 18 months, it has really been the buzz of the technology and maker community. But why is it such a big deal, you might ask? And I felt that the best way to answer this was with a Raspberry Pi chart. We'll save the rim shot there. And really, when you look at it, if you compare it to today's smartphones and today's PCs, the performance is nothing exceptional. It's not bad, but I'm not going to be able to have 20 browser tabs open and be on a video call and work on a Word document all at the same time on a Raspberry Pi. That would really be an awful experience. At the same time, it's not something I'd use to track my GPS location, stay connected with social media, and text message my friends. That's really what a smartphone's for. Truly, today's smartphones and PCs are many times more powerful than the Raspberry Pi. But when you factor in the cost, a $25 to $35 computer compared to an ultra-modern gaming PC that might be $2,500, well, for 100 Raspberry Pis, you can make a pretty powerful computer, and that would be about $2,500. I wouldn't suggest doing that. I would suggest getting maybe 2 and just having the fun that you have, but there's a huge difference to be pointed out there. Furthermore, compared to smartphones, which are around $500 each, a smartphone isn't something that you're going to want to set on a weather balloon to track altitude and temperature, but a $35 Raspberry Pi might be something that you'd think about doing right away. The size is another thing. A computer in your car would be a really cool thing. You could stream all your media and audio, but again, you don't want to take your full-size PC into your car and strap it to the passenger seat so you can listen to your iTunes. Furthermore, if I wanted to carry 50 computers around from place to place, even if they were laptops, if I tried to put 50 laptops into my backpack, I should go right to the back doctor. I can store 100 Raspberry Pis in my backpack, carry them all over the place. This also leads to further advances. We can ship them anywhere. We can ship a lot of them to a lot of people. We can get them out to places cheaply, to schools and to students and to kids and to teachers. And then the last thing is, how sad am I going to be if I break one? First of all, Raspberry Pis themselves are very robust and sturdy. Like, you would really have to do something kind of, you would have to do something pretty dumb to break a Raspberry Pi. There's no moving parts. It doesn't get very hot. It doesn't use a lot of power. It's very safe. And so when you take all of those things into consideration, if I wanted to track the temperature outside, I don't want to leave my smartphone outside or my PC outside, but I might want to do that with a Raspberry Pi. So when you take all of these things together, then you see how much potential you can have because you have a small PC that's capable of doing anything a PC can do, but it's ultra portable, and it can be used in a lot of different specific applications, and you don't really have to get worried about breaking it or leaving it outside. You don't really have to get too attached to the device itself. Even though once you do have one, you do find that you do get pretty darn attached. The core of the Raspberry Pi and Raspberry Pi Foundation is around education. And for some of the older people on here, they'll recognize the computers on the left. And back in the day, we used to have Apple IIs and TI-99s, and we used to be able to write in BASIC. And before Windows came out, we had DOS. And as computers and technology advanced, we found that there was less, we put more layers of abstraction on the computers. And today's computers, you really don't need any technical proficiency to use. You can go and create a Word document, surf the web, and do everything you need to do, and you'll never see a command line or anything but a window, and it's very easy for everybody to use computers. But that has set us back a little bit. And there's two things that I should say about that. One is that when we did have the Apple IIs and the command lines and the basics and things like that, you had to be relatively privileged to be able to use one of those devices. They were thousands of dollars. Whereas today we have a Raspberry Pi. For $25, probably less than an elementary school textbook, we should have one of these in every child's hands. Because it's going to be the best toy they've ever had because they can make anything with it. They can learn how to program like we did in BASIC, but with much cooler programs than we had. And if you have a kid who can learn how to use a Linux operating system at a younger age, then when they're in college and professional lives, every operating system they use is going to be trivial and simple for them to understand. And that's not to say that Linux is super hard to use, but it's something that's good to learn first, and then learn the easy stuff afterwards. And then, today, instead of having to buy $2,000 computers, we could spend $2,000 on things like 3D printers and put those in schools. And if we can do things like that, then you've basically put a device that lets a child build anything that's in their imagination that they can build on a computer. And that's just a really amazing thing, and the potential for innovation and just more incredible inventions are right there ready for us, and Raspberry Pi is really a big part of what's going to make that happen. The next huge thing that kind of makes the Raspberry Pi a big deal is the community. The community really took off, and I think it was a combination of an inexpensive computer. The makers really loved it because they could use these computers in a million different ways. They also love to share things in the community, and so because of this, we just had so many things take off. If you go to the Google Plus groups for the Raspberry Pi, every single day there is an awesome invention. It might be by a 5-year-old, it might be by a 50-year-old, but it's like, wow, I never even thought I could do that with my little computer. And once you start reading that every day, then you start thinking of your own ideas, or you think of combinations of ideas, and it just really opens the mind for innovation and invention. That's what makes it so awesome. The Magpie magazine actually recently had a successful Kickstarter project, so now they're going to be printing their magazines physically, and that is just a conglomeration of a bunch of great ideas and articles and more ideas and things to do with your Raspberry Pi. The Raspberry Pi community and forums are incredibly active, full of ideas, helpful people, tutorials, and guides, and just everything, shopping guides, everything you could possibly need. Last but not least, Raspberry Jams have been coming up all over the world. And essentially what a Raspberry Jam is, it's a community-driven event that brings makers and inventors and children together to get Raspberry Pis in the hands of children, to get them talking to inventors, and to letting the ideas of children get into the hands of inventors to make the amazing stuff that we've been waiting for, like flying cars and Star Trek Enterprises and lightsabers and everything. We're really close, and with technology like this, that we can combine community and educational aspects, the result is just this tremendous amount of innovation. And it's amazing to see what people have come up with. People are putting Raspberry Pis in satellites. We've got robots. We've got time-lapse trackers. We've got giant arrays, submersibles. It's just amazing what the combination of kids with great ideas and makers with the ability to use inexpensively create prototypes and things that are actually going to work in the physical world. And so to answer the question, what is the Raspberry Pi for? Well, it's really for anything you can think of. It's only a $25 investment. Maybe you just want to learn Linux. Maybe you want to go low power and you find that your $1,000 computer is just too much for you and all you do is browse the web anyway. This might be a perfect thing for it. If you have a kid and he really wants a Game Boy, maybe instead of giving them the Game Boy, you give them something where they can make the Game Boy, where they can make their own consoles, where they can make their own arcade games, and where they can innovate and create and move on and on. And that's really what makes the Raspberry Pi such an awesome idea, and it's just a great time it's a great time right now for something like this to be out. And we really the most important thing I think we can do is make sure that people know about the Raspberry Pis and make sure that we get this in the hands of teachers and kids all over the world. Then we're going to see some amazing things come of it. One of the next biggest questions that comes up to me is what is the difference between a Raspberry Pi and an Arduino? And the Arduino is another super hot topic, especially in the maker community. Very popular. It's a very good thing going on. It's also very different from a Raspberry Pi. If you're completely new to the maker movement, to Raspberry Pis and Arduinos, and you've been wondering, what should I get? I would honestly start with a Raspberry Pi first. First, because you can do pretty much ultimately everything you can do with an Arduino, you can do with a Raspberry Pi with a little extension. Second, the Arduino is a little more lower level language and it's a little more technical, so it doesn't have the simplest learning curve to get started. I'm not saying don't get yourself into it, but I'm saying that if you had to pick between the two, you might have more fun starting off with a Raspberry Pi. Well, what really is an Arduino? An Arduino is a microcontroller, and it's made specifically to communicate and control sensors and motors in the physical world. So what I think of it as is a bridge between the physical world and the data world. If I want to collect temperatures, or if I want to see how much light is in an area, or if I want to control a motor, I can take an Arduino, program it, and get it to do those sorts of things. Raspberry Pi, we just discussed, is just a full-blown computer. So the Raspberry Pi is something that you would use to program the Arduino with, or it's something that you would use to collect the data from the Arduino with and turn it into a graph or display it on a web page or something like that. There isn't really a straightforward application where you would use an Arduino to power a Raspberry Pi. Conversely, the Arduino is just a very small programmable microcontroller. And I think the best analogy would be if you think of a printer, just a regular printer. You know that the printer's got motors and it's got ink and toner and things like that in it. And inside there's some chips and circuitry that tell the printer, how much ink is left and where to move the cartridge and everything like that. That's what the Arduino type stuff does. Even when you have a printer, you need a computer to print your Word documents, to send the information to the printer and that sort of thing, and that's what the Raspberry Pi is. So they are really completely different levels of computing devices. Both awesome, both great for the community. They've both taken off, and all of the work that people putting into Arduino has benefited the applications in the Raspberry Pi. So I think that the first thing you'd want to do is get a Raspberry Pi. And if you really get into that, then get an Arduino and finally get them to work together. And then you're, really having all the fun that most of the makers that are having fun now are what everybody's talking about, you'll be a part of. So that's really the big difference between the Raspberry Pi and Arduino. Another huge question. Everybody comes to me and they're like, Ed, went to go get a Raspberry Pi. It's on back order. It says it's on back order for 4 months. And I truly have been hearing this for a year. I've got 2 Raspberry Pis, and both times I ordered them, completely forgot I ordered them, and then it was like my birthday one day, I get a package in the mail, and there's another Raspberry Pi. And that's really what I suggest to do. Don't do what I did. I would say right off the bat, order 2, and then if you kind of like it, you have one to give to a friend or a kid or a teacher. Or if you get 3, then you can have 2 for yourself, and you can have one that you're planning on doing something silly with, and you can still give one to a kid or a teacher. Pay for it. You're only going to pay $35 each, and forget about it, and then wait for that Raspberry Pi to come. You're going to have plenty of stuff to do between then, and it's not going to go away. They're not going to run out of them or anything like that. So don't go to eBay and pay $75 for one or anything like that. Most of the time, I would say now with the amount that they're manufacturing, you're going to get your Raspberry Pi in 2 or 3 weeks, even if it says that the time is much longer. Accessories. Once you go start looking for your Raspberry Pis, you're going to see a billion different things that can come with it. And I would say there are some essentials you're going to need to have to get started. Keep your budget under $100. This isn't something where you should be spending, you can easily go out and buy $500 worth of Raspberry Pi accessories, and you'll be sorry you did if you realize that this really wasn't something you're into. Spend a few dollars on just the things you need and go from there. Even still, there's just a ton of cool accessories. The one in the bottom right is actually a way to get the Raspberry Pi to communicate with Arduino devices. There's touch screens, there's a Raspberry Pi camera, there's video converters, and there's LCD screens. There's just all kinds of stuff you can get, and you could spend an hour looking at all the different things. But really, start small, and keep in mind the idea of this is a $35 PC. We want to keep it as bare bones as possible. So then there's a few essentials that you have to pick up, and number one is the SD card. And my recommendation is get 2 8GB SD cards. You're going to have one, and it's going to be your awesome little Raspberry Wheezy system that you've got running perfectly, and then you can have another SD card where you're using the experimental builds or the buggy stuff, or you have a prototype or something that you want to try out, and it's a card that you can wipe over and over again. That way, if you're ever at a point where you're like, I just need a computer, you just pop in the one card that you always know is working, and everything is going to be fine. You're going to need a PC to write your information to the SD card, and a lot of PCs have SD card readers. If you don't have one, you'll need to get a USB card reader or borrow one from a friend. You'll need HDMI cables or RCA video cables to connect to your monitor. You're going to need a USB power supply. My power supply I'm using from like a 10-year-old BlackBerry I had in my junk drawer. So, most people have an extra USB supply in their junk drawer, so I wouldn't actually go out and buy one of those. Same thing goes for USB keyboards and mice. The one key I would say on keyboards and mice is don't get anything fancy. You just want a regular USB keyboard and mouse. Anything that has lights up or has LCD screens, I find that they draw too much power from the Raspberry Pi and they cause different sorts of problems. And last but not least, you're going to need a monitor to look at least to get started. Some optional things that I found that are actually great to have, of course, a powered USB hub, and you really want to make sure it's powered. Then you can plug in as many things in your USB as you want. You only have 2 slots on the Raspberry Pi to begin with, so to have the hub makes it really convenient, and you also don't have to worry as much about power draw against the Pi directly if you're using a powered one. And a Wi-Fi adapter will get you away from having to use wired network cable. You can just connect to any Wi-Fi, and so it works very well. I would advise that you take a look at the Raspberry Pi site and look at compatible USB Wi-Fi adapters, because there's some that are out there that aren't. Last but not least, you're going to have to pick a case, because it doesn't come with a case. And you don't absolutely have to have a case, but the case is kind of what makes it, super nerdy and a lot of fun. My best advice, if you're ever trying to procrastinate finishing a presentation, get a box of Legos and make a Lego case for Raspberry Pi. That you can kill hours that way easily. The awesome nerdy way is to go to Thingiverse or someplace or even better, make yourself a 3D printed case. The red case in the middle is a 3D printed case. In the top left, I have my portable Pi case on my battery pack. It's It was a Kickstarter project that was making machined cases, and I found it's a great little durable metal case that I can keep a running computer in my backpack anytime I happen to need one. And while I was looking at this, I noticed there's a great project for a keyboard case. So you basically just carry around a keyboard. If you plug it into power, then you have a computer. Power and a monitor, of course. So the case is actually, you can go buy a case. You get cool, fancy, clear cases, things like that. But, I mean, really, with the spirit of the Raspberry Pi, I would say that the most homemade case you can get is the best one. So now we've got everything we need. We know what a Raspberry Pi is. We know what it's for. We know what we can do with it. And we've gone out and we've ordered all of our parts, and we've got everything that we need. And now, what is it exactly that we have to do? Well, the setup is not too hard, and I'm going to step you through it, and then we're actually going to look at a live running Raspberry Pi. Setup, super easy. There's two ways to do it. The newest way is called Noobs, and if you go to the Raspberry Pi downloads page, the very first link is going to be for Noobs, which is new out-of-the-box system. This is a pretty cool new build in that what it does is when it starts up, it gives you choices of systems to install. There's a media center that's sort of like a streaming video player, kind of like a Google TV or an Apple TV that you would just hook up to your television, and the Raspberry Pi can be configured for that. There's a couple of different versions of Linux that you can install on it, and so the Noobs project is really, it starts you there and asks you, what are you trying to build with your Raspberry Pi? What I would suggest doing, unless you're already a hardcore Linux user, start with Raspberry and Wheezy. That's the second link on the downloads page. This distribution that they've been working on for a long time. It's very fast. It has all of the educational components that you want to have, has all of the cool programming stuff, and it has all the essentials that you would need to use it like a regular PC. For your the PC that you're going to create your SD card on, you're going to there's a couple of different programs to use to write the downloaded Raspberry Pi image to the SD card. They're very easy to use, and I've posted some names and links up there. You can always go to the Raspberry Pi site to get more information or the most recent SD card writers. They have a lot of writers that are Raspberry Pi specific, and basically you just pop the SD card into your computer, run the SD card writer program, tell it that you want to use the Raspberry and Wheezy file that you downloaded, and it'll write it to that card. And that's really all you have to do. And then you have, once you have your power and your USB and your keyboard and your monitor, then you're ready to go. Oh, did I miss a page? Let's see. Okay. So for setup, basically, you just plug everything in, and so here's a picture of my Lego Raspberry Pi case setup. And I wouldn't really take my word for it. If you go to the Raspberry Pi site, they have a quick start guide that steps you through it 1, 2, 3, 4, 5. So you put in your SD card that you just formatted. Then you connect your display. You connect your USB mouse and cable or your hub, and connect your network wire, and then you plug in the power. And you start right up. And there's no power switch or power supply or anything on a Raspberry Pi. You basically just plug it in and it's on. You want to turn it off, you unplug it. It's very easy like that. And if you're not a Linux user, you're going to see a lot of crazy text and different colors and things like that all over the place. And it may look a little unusual. But what that means is it's actually working correctly. So you don't really have to worry about that so much. If you see a lot of what you see in the left side of the screen with a little Raspberry Pi and a whole bunch of text, it's finally going to go through a bunch of checks, and then it will get to the login. You log in as Pi initially, and the first thing it's going to do is take you into a Raspbian setup mode. And that's where we're going to move to my demo. One minute. Okay. Okay, so here's my Raspberry Pi. I call it the Snajder Pi, and as you can see, it's really just a regular little Linux machine, and this may look like the Klingon stuff I was talking about, but don't worry about that. When you first start your Raspberry Pi, if you install Rasby and Wheezy, you're going to see something like this. And basically, this screen is the initial setup screen for the Raspberry Pi. We'll step through these quick. Number one is expand file system. For your first build, I would just hit one and do it, and it's going to go through, it's going to do a bunch of things, and it's going to tell you it's ready on the next reboot. The next thing you might want to do is change your Pi user password to something that's more secure. Also another very easy thing to do. Number three is enable boot to desktop. If you don't want to see the text login and that sort of thing, and you want to just boot into a Windows type operating system, then you can select this and you can pick yes. I always like to pick no because it's I feel like I'm playing war games sometimes, playing around on the command line, and it only takes 2 seconds to get into the Windows operating system. So there's a lot of fun things you can do here. Internationalization options is an important one, in that you want to make sure that you have the right keyboard layout. If you're in the United States, you want to use the U.S. keyboard, or else you're going to find that your characters are all over the place. So be sure to pick the correct keyboard first. I believe by default it is the UK keyboard. And if you happen to get a Raspberry Pi camera and you weren't listening to me and you ordered all the accessories anyway, this is where you would go and activate it. And you can overclock it and do a lot more advanced things that I'm not going to get into on this, because that's really the deep Klingon that isn't necessary for a 101. Honestly, if you go through number 1, 2, and 3, and 4, and you enter everything like you want it, and you go to finish, then you will have a fully working Raspberry Pi. And I'm not going to reboot now because I have this open. So, once you get everything started up, you're going to have a login, and then to start everything is, there's actually 2 things I wanted to cover. One is to update everything. And if you do a sudo, this is probably the most complicated piece of code I'm going to show for this entire demonstration. Sudo update basically runs through and it checks everything to make sure that the system is up to date. Really don't have to do that. You could do it as often as you want. I recommended doing it right after initial build, just to make sure that you're running everything that's the latest and all the bugs are fixed and everything like that. So this will run for a couple minutes and it'll finish. And when it finishes, it will show you, well, we can wait for a second here. It's showing. Take another moment. I'm not expecting it will have much to update for me, but and you don't really have to know exactly what's going on in the text. It's just very, it likes to communicate with you. So once you run through your update, it'll make sure that your whole system's up to date. And then finally, if you type start X, that's going to take you into the Windows operating system for Linux. And that, I'm going to take you over here. I have a session of it. This will be the first thing you see. And as you might imagine, it looks very familiar to, if you use a Mac or a Windows or a Linux system, this is very familiar GUI. It's got a start button over here, and it's got all of, the typical things that you see. And as you can see, it's not particularly slow or unresponsive. It does do a very good job for a tiny little 5-watt computer. The cool stuff about Raspbian is what it comes with. First, I want to show you Scratch. And Scratch is an MIT project that is basically the modern-day programming language for kids. And it teaches kids about object-oriented programming and event-driven programming, and also includes a lot of just ways to be creative. It comes included with a ton of samples. So you can give this to a kid, and they'll probably have set up the Raspberry Pi before you even finish the instructions, and they're already working in Scratch by the time you've figured out how to plug things in. But it's just a super easy way to learn about programming, and for kids or for older people. If you just wanted to play around and see how programs work, this is a really great way to do it. This also works with the physical world, so it can be connected to talk to Lego devices or motors or anything like that. It can collect data. So it's not just it's not necessarily just a cat that speaks different languages. There's just a million different things. You could really create anything that you would want in the context of a programming language. So a lot of fun. It keeps kids interested. Really opens a lot of creative doors. So imagine we could get one of these little things in the hands of every kid and have them figure out if they like programming or not. We would make some amazing programs in the very near future. So Scratch is a great way to go. It's free. You don't need a Raspberry Pi to actually use Scratch. You can go to the Scratch website now and download it and start playing with it, and it's great. Another thing that it is Python comes Raspberry Pi. The actual Pi they changed it to 3.14 Pi, but I believe that the name actually came from Python in that it runs Python very well. And so once you have someone that's moved beyond Scratch and it's like, I want something with a little more meat to it, Python programming language is something that's used everywhere. And it's another great language to learn for automation, for improving, for innovation, for everything. So it definitely is a little slower than maybe your Mac or Windows PC when you start it up, but then once you're there, it works like any other. It works like any other Python editor. It's completely compatible. It's version 3, so it's the latest version. You really can't. There's nothing wrong. It runs great, and also have a browser. And I would say that for browsing, it's not the best, even though the Raspberry Pi does happen to be very good at video and audio. So if you're using specifically for that task or in a media center type application, then you'll find that it's not too bad. For browsing, if you're browsing with 1 or 2 tabs open, then it works fine. And Midori is not a bad browser. It seems to be compatible with a lot of things, and it's going to get you to a lot of places that would be applicable to the Raspberry Pi. So that was just a quick tour of what you would expect to see if you were to, once you've built and configured and installed your Raspberry Pi. Truly, once you get all the parts together and with the configuration and everything, you could probably do it in about 30 minutes. And if you give it to a kid, they could probably do it in about 5 or 6 minutes. It's really super easy, and it actually is a lot of fun. It's very difficult to screw up too, which is another thing that I think is why I like it so much. All right, and let me get back to my presentation here. Okay, so we were, all right, so that was a sample slide in case I bombed my live demo. And so, yeah, it was a quick tour of the Raspbian system, X Windows, Scratch, and Python, and it is really a great way. Let's say you just want to learn that sort of thing and you don't have a computer. Well, for $35, you can start learning it all, and it works great. There's nothing on here that you couldn't do that won't work on any other machine. If you do run into problems, and people do run into problems, there are a lot of resources. First of all, online, there's just a ton of resources at the Raspberry Pi site, on the forums, all throughout the internet. People are more than willing to help on this. They're very friendly, and it's really big. It's a community effort, and that's what kind of makes it there's such a positive force around it. The number one issue I would say is power. If something is drawing too much power from your Raspberry Pi, then you'll find that it starts acting strangely. Most of the time it is with the keyboard. I found that my first Raspberry Pi, I have one of the older models, and and by the way, the demo I just walked through is actually from one of the old model Raspberry Pis, so that's half the memory of what you would get now for $35, and I think they're actually by default a little slower, so that's at least as fast as yours will be when you order yours. But yes, going back to the power on the keyboards seem to usually be the thing that draws the most power, and if you find that keys are repeating over again, like you can never get your password in, or every time you type something, then the last letter starts repeating itself, then you're probably drawing too much power from your keyboard. There's a lot of advice on like what keyboards are compatible and what to look for in a keyboard on the Raspberry Pi site, so I'm not going to go into any major detail there. And then USB, anything that's drawing power as a USB device, that's usually where a powered USB hub comes in handy because it takes the power from that instead of taking it right from the Raspberry Pi. And finally, I have read that there are some SD cards that are not compatible, but I would imagine that they're older ones. If I could say anything on SD cards, I would say go for a little higher quality, a faster read-write one, and I don't think that there's any. I don't recall any specific details on what's not compatible in Raspberry Pi forms, but I'm pretty sure everything that's available today is going to work fine. Once you're done with the Raspbian builds, the sky's the limit. There's a ton of different things already, like active, very robust projects going on that run on Raspberry Pis. Arch Linux is kind of more, it's a little more minimalist, so you'll probably find that it performs faster, but it's a little more for advanced users. So once you became very comfortable with Raspbian, maybe Arch Linux would be something that you're interested in. RPi TV, OpenELEC, and RasBMC are all media servers. So they basically connect the web and your external drives and things like that to your television. They work with remotes through Android devices. There's some really cool stuff with the media server side of the Raspberry Pi implementations. PyMame is an arcade emulator, so if you decide you want to play every arcade game from the 1980s, like PyMame will do it. If you figure that is way more powerful than what the chip that Pac-Man used to run on, so or any arcade game. So there's a lot of interesting projects around emulating arcade games with the Raspberry Pi. There's a RISC OS that is another more advanced operating system, but it's something that was made specifically for those types of chips. And there's an Android project, though it seems to be struggling a little bit, and it hasn't had a lot of activity. Certainly not relative to the other projects I've seen. eLinux has a great list of distributions, so just check out the link, and you can look at all the different distributions. Like I said, I would start with Raspbian just to be on the. It's something that there's a lot of people familiar with. They put a ton of work into to work well with the Raspberry Pi, and it has most of the things that are on it run very well on it. So that's one of the things that makes it such a good first choice before you go on into more advanced topics. But really, once you get here, then you're into the entire open source community, and you can start contributing back, and it just becomes, it's really a great way to get involved in the community, to get involved in education, to spread the word about what an awesome little inexpensive device this is, and to hopefully get this in every kid's hands in the near future. That'll just bring us so many boons to innovation and technology and everything. So, thanks so much, everyone, for listening to me and going through my Raspberry Pi 101 and demonstration here. If you ever want to contact me or have any questions, I've left everything up here. You can find me on Google+, LinkedIn. I definitely suggest going to the Raspberry Pi org site and seeing reading their story. Their history is very interesting, and they go in much more detail than I did here. Hit me on Twitter or email, and if you have any other questions, I think I'm going to turn it back to Yez.
All right, Ed, thank you so much for a really outstanding webcast presentation. I'll just check with you real quick here. Are you able to see the questions, or shall we read them to you in the order they came in?
Oh, I do. Wait, hold on. Let's see here. I'm still a total technology noob. Okay, all right. So, do I start? I guess I would start with one, right? Or let's see.
Yeah, just you can take them from the top down. That's fine.
Oh, okay, great. Okay. Okay, so my first question from Paul Skinner. Has anyone made a Razzie phone kit that works with a pay-as-you-go SIM card? Wow, that's a great idea. As far as the SIM card goes, I don't know of one. I haven't heard one. though I know that the Asterisk project, which is an open source voice over IP phone server, there is a port for the Raspberry Pi on that, so that you could have your own essentially like phone exchange run off your Raspberry Pi. But as far as a pay-as-you-go SIM card, I bet there would be a way to do it. It doesn't really have any sort of cell phone technology built into it, so you could certainly configure it to work as some sort of VoIP device, though. Yeah, that's another great idea. You should ask around, and like honestly, every time that someone brings up a new idea, it's either an awesome new idea or someone already had that idea and they've implemented it. So I promise not to steal it though if you make $1 billion off of it. The next question from Kelvin Alvarado: what programming environments are available to develop applications for the Pi? Java, C. So you can really run anything you want on it. It is compatible with Java. I think it would be kind of slow. It certainly does run Python very well as far as you could certainly develop Python applications. C, I don't see why it wouldn't. I'm pretty sure, I'm absolutely positive that it will run C. I actually, when I first got my Raspberry Pi, the first thing I tried to do was compile a build of Postgres, and it took like 24 hours, but it worked, and that's on C. So the programming environments themselves, I think in that case, I can't imagine something like Eclipse would work, or it would be really slow on something like a Raspberry Pi. So you'd probably want to go with the VI or Emacs or something like that to program on the Raspberry Pi. Though Python does have idle, I guess that's also an IDE too. Let's see. Next question. Android on Pi, is it possible? Yes. Yes, it's possible. They found that it's very unstable and slow, and the problem with that project is that there just hasn't been a lot of energy behind it. I don't know if people just got frustrated with it or if it didn't have enough people, but there's no reason why it shouldn't work, and I think it's just a matter of the right group of people spending some more time to get it up. I believe that there's some ports of CyanogenMod that do run on the Raspberry Pi, but again, from everything I've read, they're very slow and pretty unstable. Okay. Ooh, good question. Paul Skinner, what is the max SD card that can be used with the Raspberry Pi? I don't know the answer to that. I've used 16s, and I can't imagine that there's a limitation, honestly. But I will follow up on that on Twitter or afterwards and get you an answer for that. I'm not sure if there's a documented specification or not. But yeah, one thing is beyond the SD card, what a lot of people do is they'll have a small SD card and then they'll have a large USB flash drive that is kind of their data store or something like that. So you have a small system disk and a larger data store. And I don't know of any limitations on the USB flash drive side either. But that's a good question. You definitely stumped me there. Okay. Oh, here's another great question. Paul Skinner has had a lot of good questions. Will we ever see washers, dryers, and the like for sale at the appliance store with the Raspberry Pi inside stickers on them? Or will Raspberry Pi always be a hobbyist item? I think that the answer is already out there. We do have a lot of computer-controlled devices, and what has really been missing, has been amazing me, is we don't have a lot of like home automation, like control center sort of devices and things like that. One of the things I've always wanted to do with my Raspberry Pi is like turn it into, like, make my home into a smart home where, if I get laugh track, then, a speaker plays laughter, or if I need to turn off the lights, you can turn off all the lights, or, anything, if I can yell at my house, computer, do this, then, that would be awesome. So, something I've always thought about doing with a Raspberry Pi. I think that we might not see stickers with Raspberry Pi inside, but I think we're definitely moving towards an age where things like toasters and refrigerators and washers and dryers can have a little bit of computer hardware in them, transmit to something that's more knowledgeable and make more efficiency for power, notification, and the like. And so I think we're there from in humanity's perspective. If anything, the Raspberry Pis will be the things that make the prototypes for these devices in the future. Andy Hanks, Pi versus Arduino. Can you compare speed response time for time-sensitive tasks? The Arduino may be faster for simple tasks. I would say that's true. So when you're working with an Arduino, you're working with like a 32 kilobyte register. So you can't give it a ton of programming instructions you can't give it a ton of instructions to operate on. You're physically limited by lines of code in that way. But at the same time, because it is such a specific device used for specifically controlling sensors and receiving data, I would expect that you do get very good response time. It's going to be as good as the crystal in your circuit, essentially, as far as timing things. A Raspberry Pi I could see being subject to latency, concurrency issues, and things like that because you're using it as a higher level machine. You're not really going to be multitasking with an Arduino, so it's sort of hard to compare. But if I needed to know that I needed to take a measurement every 100 milliseconds on a specific temperature device or something like that, I would probably lean towards an Arduino as being a choice over a Raspberry Pi. Good question, though. Okay, a few more questions here. Have businesses adopted Raspberry Pi or Arduino? Yes. So there's a few things I've seen as far as that goes. On the Arduino side, certainly there's been microcontroller clones, and people have created their own Arduino-like devices that are made for doing the same sorts of things. Furthermore, the Arduino movement, I think, has spurned a lot of businesses that would use the Arduino as a component of the larger thing they're selling. And a great example would be 3D printers. In the last few years, there have been several companies that have started selling 3D printers, and the microcontrollers that go inside effectively work a lot like Arduinos. They may not use Arduinos themselves, but they're conceptually the same. And typically, that's how you might prototype something, is with an Arduino, and you'd say, this is how I want to build my 3D printer, and then from there you would put it into a manufacturing process where it may be proprietary or integrated into another part of the system. As far as adoption for Raspberry Pi, I think that's another thing where it might be components-based, where businesses may start and could start cheaply and utilize a particular function with a Raspberry Pi, but as far as like Raspberry Pi stores and things like that, I don't think that's really taken off too much. And thinking about it a little, there is a Raspberry Pi application store, so they are moving in a direction where they want to make applications available to users, much like other operating systems do, and there are some paid applications there, so that would be another potential for business. So you would probably go to a lot more platforms if you really wanted to be successful there. Okay. Another question here. Business. Question: what impact does running a window manager have on performance? And the answer, great question. So it definitely runs faster from the command line with no window manager running. But what I have found is that they have done a good job with making a very light window manager, and it really only uses processor cycles when something has to load up. It seems to do a very good job of caching and utilizing the memory space, and so it's not horrible. But at the same time, if I have 5 windows open, or if I'm really trying to multitask with a Raspberry Pi, it's really not a fun experience. Not if you have a workstation or
a quad-core something sitting under your desk that performs those operations in nanoseconds, then you find that, if you're trying to do too much with a Raspberry Pi, then the X Windows, it does get kind of sluggish on you. And I think I have one more question here. Is the Raspberry Pi suitable for use in commercial applications? Is it a toy, or can I expect this to work reliably if I put it on a shop floor or in a store? Well, that's a great question. So it is considered to a large degree to be a development board. So, but at the same time, it is very robust. Like I got my first Raspberry Pi early on, so I've had it well over a year. I carry it around with me. I've dropped it. It's really done a ton of different things. One of the cool things is because it has no moving parts and because it's only using 5 watts of power and never gets very hot, there's not a lot that could go wrong with it. It's not like the chip's going to overheat or it doesn't see a lot of the conditions that cause typical hardware to fail. So on that right, like it is very reliable. When I think of it in terms of like in a commercial application or something like that, and I do think of it as commodity hardware. So maybe a MapReduce cluster or an array or something like that, it would be effective in where you're expecting some of the units to fail, but you have other ones that are backing it up. And even for like small store displays and things like that, where you just need a smart device that's doing a specific application, I think that you would have a lot of success with it. And the one thing that you may not have with reliability, it's very inexpensive for you to implement redundancy. So if you have something that is relatively important, so you get 2 and have a backup, and that may be cheaper than getting the more expensive hardware. Okay, I think that was, do I refresh here? Oh, I have a ton more questions. Wow, okay. All right. So here we go. More questions. Does the Raspberry Pi support Bluetooth over USB? A wireless keyboard would be neat. Answer is yes. Just make sure and check the Raspberry Pi site for compatible Bluetooth USB. It definitely works. I've done it myself, and totally works great with a wireless keyboard. What I find myself doing a lot is, and this is a little more advanced, is that I'll SSH or VNC into my Raspberry Pi, and then I don't actually have to have a monitor hooked up to it directly. If you didn't know what that meant, that's okay. Just hook it up to a monitor. Let's see. Another great question. How about GPIO on Pi? So general purpose input-output on the Pi. Completely, I meant to go into that a little bit. That's an interface basically that you can use for just about anything. A lot of people use it for controlling and monitoring the physical world like you would with an Arduino, or hooking the GPIO up directly to an Arduino. I haven't done a lot with it myself, but there's a ton of information out on the internet about the different things people have done with the GPIO interface and what they've connected to the Pi with. So that is a great question. I'm really glad you mentioned GPIO. If the Raspberry Pi, if you're interested in doing some kind of data collection or monitoring or tracking or anything like that, then you definitely want to look at the Raspberry Pi site for GPIO. Any example of Raspberry Pi farms for distributed or parallel processing applications? So I really want to start my own MapReduce cluster, and because it seems like the perfect little thing where you could make a proof of concept. There are a lot of people that have blogged about 64-core arrays and things like that. I don't know exactly what their implementations are, but I would say that if you go and read the Google MapReduce paper, it's almost like it was like this is the commodity hardware it was written for, like low network, may or may not fail, and a little bit of disk space. So it's definitely I think it's out there. I think we're going to see the one downside to that potential is that even though it does use very little bit of power, the power for performance is not great. So you can get more efficient systems as far as computing cycles go, which may be more advantageous to your parallel processing application. Portability. You mentioned portability and any battery type or PC car uses. In other words, to make it truly portable, any batteries you know of offhand or cigarette lighter adapters. Basically, it will run on. It needs 5 volts and 1 amp. I've run it on 5 volts and half an amp, and it seems to run okay. I think my BlackBerry charger is 700 milliamps, but those are all things that there are car chargers that will run that okay. You can configure it with a transformer to run off of your car directly, and there have been lately a lot of big battery packs, like Kickstarter projects and things like that, I have an 18,000 mAh battery pack that will run a Raspberry Pi for about a week before I have to charge it again. Lots of good stuff out there, and that way you can have, I've also seen good implementations with battery packs and solar power arrays where you can basically keep a Raspberry Pi running indefinitely if you're in a good sunny place. And then, there's a ton of autonomous little projects you can come up with there where you have a self-powered wireless access point doing something for you. It's really neat stuff, the Raspberry Pi. Next question. Is it possible to use .NET apps on a Raspberry Pi? I don't think so. I really don't know. I've only ever done anything with .NET on a Windows machine, so if there's an easy way to port to an open source operating system, then possibly, but that's a good question. I'm going to look into that, and I'll get a follow-up post or Twitter post or something and let you know. Definitely a good question. Definitely got me stumped. Next question. Can you run assembly language modules and turn off interrupts? Probably. Assembly language module. I guess for assembly language, it would have to understand the ARM controller specifically. There probably is a machine level language that I'm certain that there's a way to talk to it on the machine level for an ARM chip. That's definitely way beyond my own technical capacity with the Raspberry Pi. And turning off interrupts, I think that you could probably do from maybe from the operating system. Really good question, but yeah, definitely not one I know how to answer. That's something that is a great question to throw out to the experts in the community that know the architecture and been part of building it or contributing to the project, and there's somebody out there that knows that answer off the top of their head. I'm sure of it. Some more information about mating Pi with the Arduino. So I would check Adafruit Industries. They're a pretty popular maker online site. They have a lot of Raspberry Pi kits, and then they also have a lot of extensions and boards for using Arduino with a Raspberry Pi. So that you basically use your Raspberry Pi as a bridge to the Arduino, and your Arduino can talk back to the Raspberry Pi and give it all the data that it's collecting, or it can run printers for you or things like that. There's also a really neat Kickstarter project, and that's a great place to look for Arduino or Raspberry Pi-like projects. And basically they built a board that was the equivalent of 4 Raspberry Pis and an Arduino all kind of put together, so that you basically install your operating system, and then you're going to be able to talk directly to an Arduino programmer and have that do its discrete measurements and motor controls on its own chip by itself, while the Raspberry Pi chips do their own normal higher level processing. There's a lot of great applications out there on mating the two together, because they're both very hot topics in the maker community, because there's just an infinite number of things you can do with both of them. They're both relatively inexpensive, and so when you think of something where I want to set something off on the top of a mountain so I can see how the weather changes or what the humidity is like, or I want to take pictures of nebulas and things. Like something like that, a $50 investment, and you've got your Arduino and you've got your Raspberry Pi working together on a battery pack, and you don't really have to worry about it. So it's like a great way to make them together. I kind of lost my train of thought there. But yeah, they do mate well together, I will say that. But if you had to pick two, I would start with the Pi. Any thoughts on distributed processing with multiple Raspberry Pis? Yeah, we covered that a little bit, and yeah, totally think it is possible and relatively, that would be a fun project to set up. And I know that there are already people working on it. There's going to be some really cool stuff that they come up with arrays and Raspberry Pis. And let me get one more refreshing here. Okay, I think I got them all.
Perfect, Ed. Thank you so much. And questions continue to stream in. So, folks, we are a little over the top of the hour, and Ed has posted on the screen right there in front of you a slide with his contact information. So you've got his email address, you've got his Twitter handle, Google+, all that good stuff, and he's open for you to follow up with him after the event. Ed, we are going to say an incredibly big thank you to you, sir, for presenting just such a fascinating and fun webcast for us all today.
Thanks so much for having me. It was a lot of fun.
Folks that attended our event, we thank you so much for attending, and we hope you've benefited from it. We'd also like to thank those of you that sent in your questions, because having those questions really adds just that much more to our event, so we thank you for that. As we wrap up here, I just wanted to make a couple of announcements. Ed is speaking at O'Reilly's flagship conference. It's called OSCON, and it's in Portland, Oregon next month, July 22nd through the 26th. He's going to be talking about my RepRap printer, the eMaker Huxley. I hope I said that right. Huxley. So that for sure is going to be really exciting, folks. You can attend the session. We do have tickets available still. If you're in the Portland area, July 22nd through the 26th, please come on over. We'd love to see you all there. You can shake Ed's hand, introduce yourself, and I'm sure we can have some great conversations about all these awesome technologies. We'd also like to let you know to please mark your calendars for July 10th. Ed is going to do another webcast for O'Reilly, and he's going to talk about 3D printing for everyone, what you need to know to build your own 3D printer. So for sure that one's going to be super fun and exciting as well. Folks, in your resource widget, so in your widget tray, you have a green file folder. Ed has made available to you all lots of good links to several Raspberry Pi resources that you're going to find a lot of benefit in. As well, he's put links to Raspberry Pi events. So if you're interested in attending some meetups or some live in-person, a lot of them free events, please take a look at that. You can meet other makers out there and connect up and see what other cool things people are doing. So, again, we're going to thank you, Ed. We thank everyone for attending today. This will conclude today's webcast. Goodbye, everybody.